Hey guys, it's Kaylee. In this video, we will do some greatest common factor problems together. Grab some sketch paper and a pencil and follow along with me. Can you think of a time when you need to know the greatest common factors of two numbers when you're doing a different kind of math problem? What if you have a fraction like 36 over 108? It's hard to know what that fraction actually represents. But if we simplify it, we can understand what this fraction looks like. We can quickly simplify this fraction to its lowest terms by finding the greatest common factor of the numerator and the denominator. Since 108 is such a big number, let's use prime factorization. So 36 gives us branches of 2 and 18 gives branches 2 and 9 gives us 3 and 3. So we can write 36 is equal to 2 times 2 times 3 times 3. Okay, so now we do the same thing for 108. So 108, if I divide by 2, I get 54. And if I divide 54 by 2, I get 27. And 27 breaks into 9 and 3, and 9 breaks into 3 and 3. So for 108, I'll write it over here, is equal to 2 times 2 times, I did this kind of backwards, but it's all these 3's. 3 times 3 times 3. Okay, what's our next step? Yeah, we find those matching factors. So I have a 2 here, and I have a 2 here, a 2 here, and a 2 here, a 3, and a 3, and a 3, and a 3. So all four of those factors are going to be in our greatest common factor. So GCF of 36 and 108 is equal to 2 times 2 times 3 times 3. And this is equal to 4 times 9, which is equal to 36. So 36 is our greatest common factor of 36 and 108. So now how do we use that to simplify our fraction? Yeah, we're going to divide our numerator and our denominator by our GCF. So I'm going to take 36 here and divide that by 36. And whatever I do to the top, I have to do to the bottom. So this is equal to 36 divided by 36 gives me 1. And 36 goes into 108. If you don't know it off the top of your head, that's okay. You can use a calculator. It's 3. So this fraction, 36 over 108, is the same as 1/3. And 1/3 is pretty easy for us to visualize. Now let's see an example of the greatest common factor solving real-world problems. Jill is planting roses. She has 12 red rose plants and 36 white rose plants. She wants to plant the same number of red roses in each row and the same number of white roses in each row. What is the greatest number of rows Jill can plant? What does that sound like? Yeah, that sounds like the greatest common factor. So this is asking us, what's the greatest common factor of 12 and 36? We can use our prime factorization method to help us find that. So if we're finding the GCF of 12 and 36, I can start with my tree for 12, which is 2 and 6, and 2 and 3. So 12 is equal to 2 times 2 times 3. Now I'll do my prime factor tree for 36. 36 is 2 and 18. 18 is 2 and 9. 9 is 3 and 3. So 36 is equal to 2 times 2 times 3 times 3. Okay, that's awesome. And we know our next step is find those matching factors. So here I have a 2 and a 2, another 2 here and here, a 3 here and a 3 here. And that's it. So those are our matching ones. So what do we do with our matching factors? That's right, we find the product of it. So this is equal to 2 times 2 times 3, which 2 times 2 is 4 times 3, which is equal to 12. So if our greatest common factor is 12, what we're trying to find is the greatest number of rows that Jill can plant, which would be also 12 rows. So what would one row look like? Here's an example of one row. How many red roses will be in one row? Well, if she has 12 rose plants and she's putting those 12 roses into 12 rows, each row will have 1 red rose. Now, how many white roses will be in each row? She has 36 white rose plants and 12 rows. 12 goes into 36. How many times? Yeah, 3 times. So there'll be 3 white roses in each row. So that means each row will look like that. Good job, we crushed those practice problems. Now you're ready to do it on your own. If you need a refresher, watch this video or the greatest common factor prime factorization video to help jog your memory. Have fun and remember to always be clever.
Hey, hey.